Hi everyone, I'd like to take a moment and welcome you to the factoring video. Here we'll be talking about the greatest common factor, and then in a few minutes we'll be talking about factoring out by grouping the greatest common factor when we have four terms. So to begin with, I'd like to take a look at the following statement. So suppose we have 38x minus 2. So the idea, what we'd like to do is kind of, undo this multiplication process. So what we do is we come over here and we take a look at each term, and remember, terms are separated by addition and subtraction signs. So the question is what is the largest number, or what is the largest letter? And if there's more than one letter, then what is the largest letters that we can pull out of each term? So hopefully what we can recognize here is that there's only a letter here and there's no letters here, so there's really no letters that we need to concern ourselves with to pull out. So as I take a look at the number 38 and the number 2, if I was able to pull out a 2, then I can pull a 2 here, and then the question is what remains. So inside, hopefully we can see what remains would be a 19x minus 1. And again, we can verify our work just by using the distribution property, and to note that if I take this 2 and if I distribute it across the subtraction sign, I end up with what I started with. So let's take a look at another example. So 6x to the 7th plus 3x squared. So again, here we've got both letters and numbers in each. So as I take a look to find out what's the greatest common factor, I take a look at the numbers and I see a 6 and I can see a 3. So let's just note that we can pull out a 3. And then here I have an x squared and an x to the 7th. So the largest exponent of x that I can pull out is x squared. So left inside, if I pull a 3, I have a 2, and again here I have an x to the 5th, and I get plus 1. So again, the idea is that if we were to perform the distribution property over the addition, then I would end up with 6x to the 7th plus 3x squared. My next example is 6x to the 7th minus 4x squared plus 14x. Again, we have all of these terms here. Here we got 3 terms, and we have, again, numbers and letters. So as I take a look at the 6, the 4, and the 14, I notice that these are all even numbers. So the question is, what is the largest even number that I can pull out? And hopefully we can all see that that's going to be the number 2. And then what is the largest exponent of x that I can pull out? And here we have an x to the 7th, x squared, and an x. So the only power of x that we can pull out is just x itself. So then here I'm left with 3x to the 6th minus 2x plus 7. So our greatest common factor here is the 2x. On a previous example, 3x squared. And on the very first example, I have the number 2. So my next example then is going to be a to the 9th b to the 8th minus a to the 5th b to the 4th plus a to the 4th b to the 6th. So in this example, we don't have any numbers, so we don't have to worry about any numbers. And here I have multiple letters, so I have to take a look at each case. So here, as I take a look at the a's, hopefully we can see that the largest exponent of a that I can pull out is a to the 4th. And then over here, as we take a look at the b's, that the largest power of b that we can pull out looks like a 6. I'm sorry, b to the fourth. This guy here is the largest. So b to the fourth. So let's just note that for the first term we're left with a to the fifth, and then b to the fourth minus a plus, and then here we get, since we pulled the a to the fourth out, there's no a's left, and here we have a b squared. So again, if I distribute this over the pluses and the minus, so I take a times a to the fifth, I get a to the ninth, b to the fourth times b to the fourth is b to the eighth. Here I take a to the fourth times a, I get a to the fifth. Here I get b to the fourth. And then one more time I get a to the fourth, and then b to the sixth. So that takes care of that. And for my final example, I'm factoring the greatest common factor. Let's take a look at x, and then this grouping y plus 7 minus 7 y plus 7. Okay. So taking a look at this grouping here, again, I notice that this is really kind of disguised. I can think of this all as one term, think of this as all of another term, and hopefully what we can see is that in each one of these terms we have this y plus 7. So why don't we pull this y plus 7 out? So when I do that, I get y plus 7. And then let's just observe what's left is this x and this minus 7 here. All right, so now we get x minus 7. Okay, so again, if I distribute this y plus 7 across to the x, then I get the x y plus 7. Then if I distribute it over here, I get this final term here. We're going to kind of use that in our next upcoming example here. So let's take a look at x cubed plus 7x squared plus 2x plus 14. And in this one here, we notice that we have 4 terms. So kind of a secret here is when we have 4 terms, and in this one I'm observing that I have a x raised to the third, a variable raised to the second, to the first, and to the 0 power here. So I have this polynomial that's going from largest to smallest in exponents. So this factor by grouping says to take the first 2 terms and group them together. And then take the second 2 terms and group them together. So now what we have to do is take a look at our first grouping and ask what is the greatest common factor. So with this one, we can observe that the greatest common factor in our first grouping is just going to be an x squared. And notice here I'm left with x plus 7 plus, and here on our grouping here, our greatest common factor is going to be a 2. And here I'm left with x plus 7. And again, notice that in each one of these terms, I have an x plus 7, so I pull out the x plus 7. And then notice I'm left with an x squared plus a 2. So that's how we can get that guy factored like that. All right? So let's take a look at another example. This one's going to involve 2 variables. So let's note that we have 2x plus 10 plus an xy plus 5y. And again, here I got 4 terms already kind of arranged for us. So let's group the first 2 terms together. I get 2x plus 10 plus, and group the second 2 terms, xy plus 5y. Okay, so in this case, I take a look here and I'll notice that I have a greatest common factor between these first 2 terms is 2, and I'm left with x plus 5 plus, And then notice here, my greatest common factor with these two terms is a y, so I'll pull a y, and now I get x plus 5. And again, notice that we have an x plus 5 that's common in both of those two terms. So pulling out the x plus 5, I'm left with 2 plus y. And again, as I did previously, we can always go back up and perform the multiplication, okay, using a FOIL method to verify our work. Again, I'd like to take a look at another one involving two variables. So let's take a look at a little bit different. But hopefully you're kind of starting to see a pattern. So 2x squared minus 10xy minus 9x plus 45y. Okay, so again, we have for our four terms, so let's go ahead and employ our grouping. So I'll group the first two terms, 2x squared minus 10xy. Now here we have to be careful. Notice this third term has a minus. Okay, so when we go to factor or group these together, remember we got to make sure that minus when it distributes across. So here we'll get minus. So now we're going to get the 9x. Notice this becomes positive, but the last term becomes negative, because again, when we distribute, we need to get this one here to be the 9xy, and then when I distribute here, we need to get the plus 45. So the moral of the story here, if you want to pause and write you a moral of the story, is the fact that when the third term is negative, you just got to flip the signs on these guys. All right, so let's notice here we got a 2 and a 10, so 2 looks like it's common, greatest that we can pull out. And here we got an x in each one, no y's to worry about, so I'll pull out an x. So here we're left with x minus, looks like 5y, minus greatest common factor here, I'll factor out a 9. So here we're left with x minus 5y. And again, we have our x minus 5y, so we can pull that out. So when we pull out our x minus 5y, then we're left with 2x minus 9. So that's completely factored. We can go ahead and stop there. Okay. And then let's take a look at I got one more here. How about 7x minus 7 plus x cubed plus 9x squared? So in this one, what I'm observing is that we have a polynomial with four terms, but let's just notice that the terms are all out of order according to the variable raised to the exponent. So probably a good idea would be to reorder these terms. Okay, so I'm going to reorder these terms in the form of x cubed plus 9x squared plus 7x minus 7. And again, I'm going to group the first two terms of x cubed plus 9x squared plus 7x minus 7. Okay? And I'll go ahead and group those two terms. So here in our first grouping, we got x squared. So we're left with x plus 9 plus 7. So we get x minus 1. So here we can observe that there's no, notice that these are not the same. Like everything else, as you go back, when we got to this point on grouping and then factoring out the greatest common factor in each grouping, we had these guys here being the same, and here they're not. So we cannot fully factor this one as a product of factors That's what this is, a product of factors. This is a product of factors, a product of factors. In fact, if I go all the way up, product, product, product. Okay, so to be completely factored, we need this product of factors. So I don't get product of factors, so I'm just going to write no product of factors. So when we can't factor to a product of factors, then we say that this is prime. Kind of similar to the concept of prime numbers. So prime. All right. Okay, so this is my learning video for factoring out the greatest common factors, and again, a technique of factoring greatest common factor by grouping. I hope this helps you out. Thanks a lot. Bye.